Alright, so today we're going to continue our discussion into exponents. And again, exponents is simply a shortcut notation for us to do multiplication of a variable or a digit a certain number of times. So x times 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 x n times is x to the n power. And again, we have a few rules we already know. One is that just x is equivalent to x to the 1 power. We don't have to show the 1 here, it's understood. And if it's x to the 0 power, it's not multiplication by 0, it's x raised to the 0. That is 1. And if we're going to do a negative n, we have to make it positive by moving across the fraction line, and it's 1 over x to the n. These are things we know. We also know two other rules. We know the product rule. X to the m times x to the n is equivalent of x m to the n. And again, this is the rule x cubed x to the 9. x3 and x9. 3x's times 9x's, oh, I can't get my thumb out because of the cap here, hang on, is 3 plus 9. Well, that's x to the 12. Alright? And we also know the quotient rule. And again, if we have something on the bottom, we can bring it up. And we've talked about this in class. If I have x8 over x4, well, if you bring x4 to the top, it becomes x to the negative 4 when you move a term across the fraction line, and it's one term on top, one term on bottom. There is no summing or differences here. It's all multiplication. Very big point. You can take this to the top, x negative 4, 8 and negative 4 make 4, or just look and say 8 minus 4 is x4. And that's the quotient rule shown here at the bottom. These are all rules you should have in your notes. Today we're going to add basically the last rule of exponents. So, again, I have two examples here. x2, x3, x7, x. 2 and 3 make 5, 5 and 7 make 12, 1 more x because there's a 1 here, makes x to the 13. y2, y negative 4. 2 plus negative 4 is negative 2. That would be all in the numerator. Often I ask you to write it positively. Since it's one term, all multiplication, no sums or differences, I can do this. Quotient rule, let's just make it all in the numerator this time. That's the other thing I get to ask for. x3, x4, that's x to the negative 1, correct? y7 minus y9. y2. How about y negative 2? a4, a3, 4 minus 3, a to the 1, which I can just write as a. And again, these are our two existing rules. So the question is, x to the 4th raised to the 3rd. So does that look like either the product rule or the quotient rule? So does this thing right here look like this or this? Well, obviously it's not a quotient. But I would argue it doesn't look like the product either. It has two exponents and only one variable. So neither is the right answer. X to the 4 to the 3rd. So I'm going to go back to the idea of a to the n is equal to a times itself n times. So I have a cubed, I have a times a times a. Well, I have a right here. A is this junk inside, a to the 3rd. So I have x to the 4th to the 3rd. So that's just like x to the 4th times x to the 4th times x to the 4th. Which we write x4, x4, x4. We don't need the multiplication symbol. Well, we know how to do this. This is taking us back to the product rule. And that makes x12. Well, and I'm telling you, these are equivalent. Well, I want you to start watching for shortcuts here. Alright, but we're going to do another problem first. I have 2x cubed y squared, one term, no difference, no sum. And I have it cubed. So I got to do that 3 times. That times that times that. Well, I can write this in any order I want, because multiplication can be written in any order. 1 times 2 is 2, 2 times 1 is 2. So I'm going to write all the 2's first, all the x cubes second, all the y squareds last, and it's all multiplication. Well, we know this is 2 cubed, that's 8. x3, 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 well that's x9. y2, y2, y2 is y6. Then I go to the question mark, is it equivalent? You can plug in numbers. We change that to an exclamation point. It is equivalent. And the question is there a shortcut to get from here to here? Because these problems get awfully big if we write them out every time. It'll work, but they get awfully big. That leads us to the power rule, and maybe you saw it on the last board. When you have something raised to the m power, you can go to the and raise it to the n power again, 2 powers. It's a power rule. You can multiply. So in that last example, if I have x7 cubed, well, it's doing x7, 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 but instead of doing that, you can simply shortcut to x21, m times n. The coefficients multiply. A power to a power is multiplied. Not to be confused with the product rule, where you add the exponents. So, and again, I show over here some reasons you could look at, because, you know, xm done n times is nm, or mn. I did it for n equals 2, and I did it for m equals 4. It comes down to you can multiply the exponents when it looks like this. Now here's the case where I want to make sure you understand that it doesn't have to be just a numerator. It can also be a denominator. So I have 3x cubed y squared raised to the negative 2. Now I could drop that below the fraction line, right? Make the exponent positive, which I did here, and then multiply it out. But we want to use the power rule because this will get way too cumbersome as things get too bigger. So I do the power rule. The negative 2. Remember, there's a 1 on the 3. And a lot of times I see students do the lines. It is multiplied by all the things, exponents inside. There are 3 factors, so the power has to multiply 3 times. Negative 2 times 1, negative 2. Negative 2 times 3, negative 6. Negative 2 times 2, negative 4. And again, now this is something we know how to deal with. Bring the y4 up, bring these 2 factors to the bottom. y4 over 3 squared x6, well 3 squared is 9. And we have an answer. So I have 4 examples I'm going to work through on the board. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. And I'm going to start with the exponent and do the power rule first. And I'm going to talk about how many factors there are in the problem. If we look at Quadrant 1, we're going to start up here. 1, 2, 3, 4 factors. I see 4 things that are multiplied, thus the power on the outside has to go to all 4. So I'm going to put a 1 on the 3 first so we remember to do that. Negative 2 times 1, 3 to the negative 2. Negative 2 is positive 4. 5 times negative 2 is negative 10. Z to the 4 times negative 2 is negative 8. And often the denominator gets overlooked. Now, we have to move all the negatives to the bottom and leave the positives on top. So y negative 10 is going to the bottom, 3 negative 2 is going to the bottom, and z negative 8 is going to the top. So I get x4z8 over 3 squared y10. And again, I'm a little lazy. I have an eraser board. You'd probably rewrite the problem. I'm going to change that 3 squared to 9. And again, anytime you want to try this, pause, then watch the answer. Try the problems ahead of me. Here I have 2, a negative 2, b10, all raised to the negative 3rd power. Again, how many factors are there? 2, a, and b. 3 factors. I'm not going to put the 1 on the 2, it's there, so I bring it in, do the power rule first. 2 to the negative 3, negative 2 times negative 3 is a to the positive 6, b to the negative 10. Again, now it looks like our old problems. I will take the 2 things down that are negative. And this time I will rewrite just like you guys have to. A6 over 8b10. Now I have a quotient, but how many factors are in quadrant 3? The 4, the x, the y, and the m negative 2. And again, the exponents on all the numerators, 4, x, and y, all are 1. So that 2 comes in, and that becomes 4 squared, x squared, y squared. In the numerator, 2 times negative 2, is negative 4. So I bring that to the top, and I'm going to square this 4 at the same time. 16x squared, y squared, m to the 4th. And again, you could write this in any order. We would just want the numeric coefficient to be first. Last one, well, now I want you to notice there's this chunk times this chunk. I got to do the power rule twice and separately. So I'm going to start on this one. I count the factors. 1, 2, 3, 4. But before I do anything, what's x to the 0? X to the 0 is 1. So I have 3 times 1, y negative 1 over z. Well, what's 3 times squared? But what is 3 times 1? Well, 3 times 1 is 3. So by doing a little simplification first, I only have 3 factors to worry about. 3, y negative 1, and z. I'll take those as a second power. I get 3 squared, y negative 2, z squared. On the next problem over here, I get 2x squared and y, 3 factors, all raised to negative 2. And I'll write that right down here. And since this is nothing shown, it's multiplication. 2 negative 2, x negative 4, y negative 2. Alright, now I have to bring the 2 negative 2 down, y negative 2 up. Before I even do that, what do we notice? Y negative 2, y negative 2. They're exactly the same. It's all multiplication, all factors. And now I'm left just with these 2 negative and this here. So I'm going to bring those to the bottom. I have 9 on the top over z squared, 2 squared, x4. And again, we don't leave it in that order with the power. We'll bring it here to the middle for a final answer. 9 over 4, and I'll put it in alphabetical order, x4, z squared. Again, this is the power rule. Remember that there's factors. The last thing I want to make sure you're clear of is we cannot bring that factor 2 into this problem. This is not x squared plus y squared. It is a sum, and we are not allowed. We are not allowed to do this. In this case, you'd have to write it out, and it's binomial. And when you multiply 2 binomials, you get a trinomial when you square it. You square a binomial, you get a trinomial. Again, just take some practice, add the product rule to your notes.